On this video, our primary focus is to learn how to determine the equation of the asymptotes, how to sketch this graph without focusing on the x and the y intercept. So you can try to pause this video and try to sketch this graph and see if you can get it right. So the first question, it says that y is equal to 2x minus 1, as you can see there. On our previous video, we say that in hyperbola, it goes with this equation, which is ax plus q, whereby our q is the vertical asymptote and the value of a, it determines the shape of the graph. Perfect. So now let's start with the equation of the asymptotes. We have two equations of the asymptotes. The first one that I want you to nail is the x one, the x asymptotes. The x asymptote is always going to be equal to 0, and the y asymptote is equal to the value of q. So what is the value of q here? It is -1, which is this standard this here is going to be -1. So why is this important? Why the equation of asymptote is important? It is important because when you want to draw your graph, you will need the equation of the asymptotes. So we're going to draw our graph something like this. So first thing, we're going to locate our asymptotes. What is our asymptote? The first one is x, which is equals to 0. Remember, this is the y-axis and this is the x-axis. So the equation where x is equals to 0 is where is here. The x is equal to 0 here because this is from the origin. So this is our first asymptote. The second one is when y is equals to -1. So -1 is the asymptote like this one. So y is equals to what? To -1. You might be wondering why I didn't draw the dotted line to indicate the asymptote of x. The reason why it is because it passes through the origin, the origin of our Cartesian plane. So it will not be visible even if I draw it there, this kind of equation of the asymptote, So now we're going to focus on the shape of our graph. We talked on our previous video, we said that when the value of a, it is positive, our graph is going to be stand something like this, and then when it is negative, our graph is going to stand something like this. Perfect. So what is the value of a here? The value of a, it is equals to 2. Is it positive or negative? It's positive. So when it is positive, it's going to stand in this shape. So our graph here is going to be something like this, and it's going to have another point which is there. So what I want you to also pay close attention here is that this graph, it does not touch these two asymptotes that is here. It does not touch the x value asymptotes and the y value asymptotes. The vertical and the horizontal asymptotes, it does not touch those two asymptotes. And another thing what I saw on a lot of my students when they're drawing this graph is that you will go with this original Cartesian plane, which is this one. You will draw this graph like here, and then you also draw another one, I don't know, something like this. This one, what I want you also to understand here, whenever we draw the vertical and the horizontal asymptotes, the vertical and the horizontal asymptotes, they create a new Cartesian plane. So when we draw our graph, we are following that new Cartesian plane. For example, here we draw this horizontal asymptotes and the vertical and the horizontal asymptotes. So our graph is going to go following what? Following this kind of asymptote that we just drawn here. So hence the shape of this kind of graph is going to be like this. So let's practice on the next one. So for this one, first I'm going to first determine the equation of the asymptotes. The equation of the asymptotes, the x1, the horizontal one is always going to be 0. The vertical one, the vertical asymptote is equals to value of q. The value of q is the number that is here, which here it is 2. So I'm going to draw our graph. So our graph is going to something like this. And then the y value, the x value is going to be x, which is equal to 0. So this one is not necessary to indicate it. Your teacher may not talk about this one, but I want to talk about it because it's going to help us on our future videos so we can be able to understand them. So then the y values, which is going to be somewhere here. So this is y, which is equals to 2, So now we're going to just take a look at the value of a so that we can be able to determine the shape. So the shape here, the value of a, it is what? Is it negative or positive? It is negative. It is less than 0. So while it is less than 0, where are we going to draw our graph? We're going to draw it here, which is the first one, and we also have to draw it here. Notice that this kind of graph, it does not touch the vertical and the horizontal asymptotes. It doesn't touch these asymptotes and does not touch these other asymptotes. This is the behavior of an hyperbolic function. And another thing I'm repeating again, I saw a lot of students when they draw this, they draw the graph here on these kinds of Cartesian plane, the original Cartesian plane. You have to draw a graph following the Cartesian plane that has been created by the asymptotes. Then you draw your graph following the Cartesian plane that has been created by what? By the asymptote. So it's going to stand as this blue line and also this one. So I'm not going to indicate it on our next questions that are going to be there. So the next one is this one, which is y, which is equal to negative 100. So first we're going to determine our asymptote. Is going to be x is going to be equal to 0, and y is going to be equal to what? To 1, And then we're going to draw our graph, which is this one. So let me just focus mostly on the asymptotes. So this one is going to be y, which is equals to 1. So what will be the shape here? And another thing that I want you to also note is that the value of a, the number that is there, it does not matter. What matters the most is the sign. Is it positive or negative? So don't be worried when you find the number that is bigger or small. No. What you need to understand is the sign that is there. If it is negative, you know the shape is going to be like this. If it is positive, it's going to be like this. So what is the value of a here? Is it negative or positive? Here it is negative. It is less than 0. And when it is less than 0, it is going to be found here on this quadrant, and also where? And also in this quadrant, Perfect. So this is going to be, look at me, I didn't draw it correctly, but this, you can be able to see it where it is right now. So also note, it does not touch the asymptotes, this kind of graph here, So this is the type of graph. So now let's just take a look at the last one. What will be the equation of the asymptotes here? The x value is going to be equals to 0, the horizontal one. The vertical one, what is the value of q? The value of q is equals to what? It's equals to 0. So the y is going to be equals to 0. So where will be our asymptotes here? You might be wondering, where will be our asymptotes? The asymptote is going to be on the origin. X is going to be equals to what? To 0. And then y, it is going to be equals to what? To 0. So our asymptotes here are on the origin. Perfect. This is where your teacher will start to show you this kind of stuff in this kind of graph, So what is the value of a? Is it positive or negative? It is positive. So it's going to be here, It's going to be somewhere here, and also on this kind of stuff. This graph, it does not touch what? It does not touch our asymptotes, which are x, which is equals to 0, and y, which is equals to 0.